Hi guys, my name is Karla and today we will be talking about the Doppler effect. Before we start, I would like to explain what is the Doppler effect.
So, you may have noticed that when an ambulance or police car goes past, its siren is high pitch as it comes toward you. But when it goes away, the pitch becomes low pitch. This effect is called the Doppler effect. Since I don't have a police car or an ambulance, I'm just going to demonstrate to you with myself. So, you will be the observer and I will be the source of the sound, and I will walk right past you and let's see what happens. The Doppler effect can be described as the effect produced by a moving source of waves, in which there is an apparent upward shift in frequency for observers towards whom the source is approaching, and an apparent downward shift in frequency for observers from whom the source is receiving. Well, this effect is a result of a change in frequency and wavelength. So, if you are standing, for example,
So the lady will be the observer and the car will be the source of sound.
when a source moves towards an observer, the observed wavelength decreases and the frequency increases. When the source moves away from an observer, the observed wavelength increases and the frequency decreases. If you're still far away from the source, the waves will arrive to you more spread out, so the sound waves have a longer wavelength but a lower pitch than usual. If you stand close to the source of sound, the sound waves arrive to you bunched together, so the sound would have a shorter wavelength but a higher pitch than usual.
Now let's start using the Doppler effect formula.
In general, the formula looks like this,
But if you notice, there's a plus minus sign because it will be different in every different situation.
To start, I will tell you what does each letter represent. The O represents the observer, the S represents the source, the V represents velocity, F represents frequency. In this case, the observer stays and the source of sound, which is the car, is moving closer to the observer. Therefore, as the observer is stationary, her velocity will be zero. But as the car is moving closer to the observer, the velocity will be minus, therefore it's V minus Vs. So the formula will look like this. However, in this case, the car is moving away from the observer. Therefore, as the observer is stationary, her velocity will be zero. But the source of sound is moving away from it. Therefore, the velocity will be a plus. And the final formula will look like this. However, in this case, the observer is the one who is moving closer to the source of sound. Therefore, as the source is not moving, its velocity will be a zero. And because the observer is the one who's moving closer to the car, its velocity will be a plus. And its final formula will look like this. Now in this case, the source is stationary and the observer is moving away from it. Therefore, as the source is not moving, its velocity will be a zero. However, as the observer is moving away from the source of the sound, its velocity will be a minus. And the final formula will look like this. What is the frequency heard by a person walking at a 15 meter per second toward a car honking if the speed of the sound is 240.6 meter per second and its frequency is 800 hertz?
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Thank you for watching and see you next time!